Hello again everyone. In this video we're going to learn how to calculate our time, speed, or distance using the front side of the E6B. The nice thing about most E6B flight computers is if you forget how to do this, it will actually tell you on the face of the E6B how to come up with these values. Before we get started, just a reminder of the scales of the E6B. The outermost scale is the A scale, which is right here. The middle scale is the B scale, and then the inner scale is the C scale. In this case, for the calculations that we're going to do in this video, the B scale represents minutes, and the C scale represents hours. In our first example, we are going to have some known values of airspeed and a known value of distance, so therefore our unknown value would be time. So if we know our airspeed and we know the distance that we would like to travel, we can use the E6B to determine how much time it will take to travel that distance at that speed. Again, if ever in doubt, we can look at the front of the E6B and it will tell us how to come up with these values. So again, we have a known value of speed, which in this example we'll say is 160 knots. So according to the guide on the front side here, we're going to place an arrow that would be on the B scale, and we will place that underneath our speed, which would be on the A scale. The arrow that we will use is right here. It's commonly referred to as the 60 index because that arrow lines up with the number 60 on the C scale. So we're going to move that 60 index, move that arrow to our known speed, which is 160. Don't forget the concept of the floating decimal. So we're going to line that arrow up with the number 16 on the A scale, which in this case the number 16 represents the number 160. Now we're going to find our distance, which is our other known value. So our distance would be found on the outer scale, on the A scale. The distance was 110 miles. So again, with the floating decimal, we're going to be looking for the number 11 on the A scale, which is right here. So we're going to call that 110. And the B scale will reveal our time in minutes to travel 110 miles at 160 knots. So here we have the number 40. So this tick mark would represent 41. This tick mark would represent 42. So we're looking at about 41.5 minutes to travel 110 miles at 160 knots. In our next example, let's say our airspeed is still 160 knots, but we wanted to determine how much time it would take for us to travel 1,100 miles, or 1,100 miles. So we don't really have to move anything. Our E6B is already set up from our last example, so our 60 index is underneath our speed of 160. If we look at the A scale for our distance is 1,100. Again, per the concept of the floating decimal, we're going to use the number 11 on the A scale to represent 1,100. And once again, we can look right below on the B scale to figure out our time. Obviously, it's not going to be 41.5 minutes this time. It's going to be 415 minutes to travel 1,100 miles. That's probably not the most practical unit to use, so we can now look on the C scale instead. And that'll tell us that it would take us about 6 hours and 50 minutes. So we're looking at this tick mark right about here. So this tick mark, obviously right here you have 6 hours. This tick mark would be 6.5 hours. So this would be 6:40, and this tick mark would be 6:50. So we're looking at about 6 hours and 50 minutes approximately. Probably 6 hours and 55 minutes to be exact. In our next example, we'll say that the unknown value is our speed, so we know how much distance we traveled and we know how much time it took us. So this would be a common problem that you would encounter in the airplane. With your timer, you would figure out the time it took to travel from point A to point B, and you would know that distance, and so therefore the unknown variable would be the ground speed. So in this example, we'll say that the distance we traveled was 14 miles, and it took us 9 minutes. So in this example, we're going to find our distance on the A scale, which was 14 miles, and we're going to align that with our time on the B scale, which is 9 minutes. So we've got our number 14 right here on the A scale. And now we will align the B scale, the number 9 on the B scale. We'll use the number 90 to represent the number 9. Align that with the 14 on the A scale. And now we're looking for our arrow, or our 60 index, which is right here. And that will reveal our speed. So this number here is the number 90. This here is the number 100. So if this tick mark represents 95, then we're probably looking at about 93 knots ground speed to travel 14 miles in 9 minutes. In the next example, we'll say that we know our speed, we know the time, but we do not know the distance. So we are looking to determine how much distance we will travel at a given speed over a given amount of time. So we'll say that our speed is 93 knots in this example, which we already have set on our E6B from the previous example. Our time, we'll say, is 120 minutes or 2 hours. So we can either look at the C scale, we can look for the 2 hours on the C scale, or we can look at the 120 minutes on the B scale. And we find those values right there. So because our 60 index is already set to our speed, we'll just look above the B scale, look at the A scale to determine the distance. So we have the number 18 right here and the number 19 here. Now if we think logically, 93 knots, that's 93 nautical miles per hour. Therefore, we know that we are going to travel approximately twice that distance, so approximately twice 90, since it's going to take us 2 hours. So instead of the number 18, we would expect this to be the number 180, and this number 19 would be the number 190. So this tick mark here would represent 182, this tick mark would be 184, and this tick mark would be 186, which is aligned with our time of 120 minutes in 2 hours. So at 93 knots over 120 minutes, we would travel 186 miles. Again, if you're ever in doubt on how to determine your time, speed, or distance, always look at the front side of the E6B. It should have a handy reminder of how to figure that information out. Whether the known value is speed, distance, or time, it doesn't matter what your known and unknown values are. As long as you know at least 2 of the values, you can figure out the third unknown value using this method. Later on, I'll show you how to figure out short time, speed, and distance problems that uses a different index than the 60 index. That's a little more advanced. We'll get there eventually. But for the next video, I'll show you how to determine your fuel burn and your fuel burn rate.